Let's work with collisions. I'm going to detect the Roboball again, and I'm going to add a collision event. We're still going to use control for now. Let's add event on activate, which is called local event, and simulated body dot get of collision begin events when it starts with the light, entity when it's actually detecting. Let's run this. There's something on this is that you would need to connect this to a function, and let's call this to on collision begin, and that is another function that we should get. And for now, let's make it very easy to do a debug print over there. That's control on collision begin, and then debug log. Ouch. It will say ouch every time it hits the floor and be very overdramatic. It's a very overdramatic Roboball. We have this is what I want to show. The error is showing that I'm trying to index a null event or null value on number 15, which means is that it's able to try to connect this event. And this is supposed to be the start of the game, but how I found out last time is when the game starts, the physics don't start. There's no collisions to begin with. It's a bit confusing. It took a little while for me to figure it out, but I figured it out. What that means is that you would need to add this on the function called control on physics enabled entity ID, and let's add that all to that function. And then I should no longer have an error. Ouch, ouch. But constantly when it's colliding with the floor, it will say, oh, it's definitely being overdramatic here. Maybe we should let it know it's the floor, but won't say ouch all the time. We wanted to differentiate between collisions, which means that I need to, the ball needs to know that the ground that is hitting is all. That means is that we need to add another property that we're going to expose to the editor. Again in the Lua script, then ground ID is entity ID. And then instead of ouch, let's comment out debug log and say if toString is the same as the collision get body to entity ID, which means is that the body that you're actually colliding with is the same as the cell properties or the ground ID. Then, and you have to also end with every if of an end, say debug log floor. Makes a mistake because it cannot be found in the entity table. Usually if you play it once, then it will find it in the entity table, so you can find it here. What we do is we take the ground entity and we put it right here. Now, because this property is exposed to the editor in the Lua scripts, it will replace this entity ID with the actual ground ID of that ground entity. Ground ID with a lowercase ID. Floor, 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 floor. It now recognizes the floor. It's still very chatty, but at least it's being less dramatic. I'm going to make a new script, an local script of mine that I've used before. Now replace all the control with autonomous. Seems to have to go everything. I'm going to then replace the scripts with the autonomous control one, and now we would like to change the actual material of the Roboball, because I said before we're using a very bouncy material that doesn't have any friction whatsoever, which is very unrealistic. So we're going to change it back to rubber. And that was one of the standard common assets that they had here, which is rubber. There, rubber. What happens? It dies. It doesn't die, but it's not really bouncing anymore. So let's go back to the scripts, the Lua scripts. So we want to give it an impulse based on at least the velocity that it hits the ground with. Let's do that on collision then. So let's get the linear velocity. And then I also want to get the mass of the ball as well, which you also can get to the rigid body request bus. But event.get mass, I guess you can also do that on physics activate. Local bounce impulse is going to be Newton per second. So, and it like forces is like is mass times acceleration. So then it's actually the impulse is then mass times velocity. I want it to stay at a certain height. So then the 6 is just like an arbitrary number. And then I'm going to apply the rigid body impulse on the Z axis right here. Then let's see what happens. Let's copy that. Let's do it in the apply, also in the collisions. Whenever it hits the floor, that's when it will actually activate with the floor. Then I would like to have this forward impulse when it's connected, so that it will not only do a bounce, but do a forward bounce. So let's copy paste this to this part, to the collision event function, or how it's called. Yeah. And then this is going to be the impulse that I was using before, but then we're only going to apply it on the time of collision, which means it's not every tick. I already know what happens, but the forward impulse is going a little bit forward, but not that much. We definitely have to make the forward impulse a lot bigger. Oh! Whoa. Change the camera rig. You have to use target rotation. I'm just going to turn it off for now. Okay. That's why, because the rig was actually directly on the transform and was also using the rotation, so it was actually rotating around the ball. So you don't want that, obviously. And that actually was a way more natural feel to the Roboball. It was actually like how it's actually supposed to be. Yeah, that is definitely something that you would rather want. I'm going to do something different. I'm going to start a new control variable called control heading. I'm going to add like a self control heading is self control heading times value times self properties angular velocity. Yep. Let's make sure that this doesn't go wrong. E. There you go. Good. All right. That was a very high control. It goes up very quickly, but I think that's because I still have it on held, so I'm just going to put it back to on pressed. Also, you can kind of see it changing, but I'm definitely going to also put some of the values down with like the angular velocity that I actually want to add, which is technically not an angular velocity anymore. I don't want the control heading to go a little bit too quickly, but we also want to do something with the control heading as well. This control heading is now not yet implemented, but let's first implement it for sure. That's now the actual body fixed impulse vector is based on this control heading itself. So instead of getting its own heading, which is now all over the place because now it's rotating, do it here based on the control heading. The reason why I want to use a control heading instead of like its actual heading, because that is now not helping out. I'm changing this in the wrong place. I have to put all of these in ones out, so I'm not making mistakes again. Probably have to clean up the code at one point. And there you go. Cool. Well, it's only cool if it works. Let's go towards the direction that I want. Seems so. That should go this way. Come to me, come to me. But if I go over, it definitely goes over more pi. It looks like a ball that you can control. I have to rub this angle, because if this is the control heading and it goes from minus pi to phi, I need to wrap it. So I'm going to just make a function in that. Let's do it all the way on the top, called function wrap angle, and then ends, and then it returns the angle. We'll wrap it between minus pi and plus pi. So I need to do that with the control heading that I have calculated right here. Wrap angle, and then in the brackets. And then once I rotate it, then it should one point, yeah, it wraps it between minus pi and pi. The only problem is that if I just make it go like this, I don't know if you noticed it a little bit, because now it's giving it a forward impulse every time. It goes faster every time it hits 4. I think we should be able to detect that from the forward velocity. We already get the velocity, but we just want to see the forward velocity. If you do debug log and velocity dots x is forward, it would be easier for us to see if I turn off the heading, control heading, debug, that it's constantly going faster. There you go. So every time it hits the 4, it does so with a much faster going speed. I don't know what they have, aerial friction at one point. Physics will stop it. It seems to have now around 9-ish or so, but it's still going faster. I don't want the ball to constantly go faster. I want it to be a little bit more controlled. I would like, let's say, similar to the bounce impulse or simple proportion. It is something that we can definitely implement. If we change the forward impulse, let's say not properties impulse size, but let's say forward velocity, not using the rotational thing anymore, so I can remove that. Local forward velocity is velocity.x times math.velocity. Control heading by going from a local coordinate system back to a world coordinate system, and then the local forward impulse, the control signal, is going to be then mass times 6 times minus the forward velocity. That's the forward velocity relative to the ball's coordinate system. And then the impulse size is going to be this. Let's see if it still goes faster. It now stays around like 5.5. We got a very simple proportional gain controller here. Okay, this is a little bit more hard coded. Of course, you can change that to be different, but I'm going to clean up the code before we continue. Can I still control it? It would be nice to have an arrow that indicates the actual direction of the control heading. But on the other hand, I don't want it to be that much controllable, I want it to control itself.